In this video, we're going to go through emission spectra, and we're going to answer the essential question, how do the concepts of ground state, excited state, and emission spectra help us identify elements using spectroscopy and diffraction grating? So let's talk about the ground state. The ground state is the lowest energy state of an atom or a molecule. In this state, electrons occupy the lowest available energy levels, or orbitals, around the nucleus. Atoms in the ground state are stable, meaning they are not emitting or absorbing energy. Now, the excited state occurs when atom absorbs energy, causing one or more of the electrons to move to a higher energy level, which would be further from the nucleus. This state is unstable, and the atom will quickly return to the ground state. As the electrons return to lower energy levels, they release energy in the form of light, which we refer to as photons. The energy release corresponds to specific wavelengths of light, which we see as lines in an emission spectrum. So here on this graphic, you can see that we have two atoms, one in the ground state and one in the excited state. Okay, so our atom here in the ground state, if you notice, we have an electron right here. And when it moves to the excited state, it's actually jumping from here up to the excited state here. And it can't stay there forever. So when it releases a photon, it's going to move back down to the ground state, and that photon will get kicked out. Emission spectra are bright lines or bands on a dark background, each corresponding to a specific wavelength of light emitted by an atom when it returns from the excited state to the ground state. So again, I'm talking about the photon that's kicked out when I'm going from the excited state back down to the ground state. Each element has a unique emission spectrum, often referred to as its atomic fingerprint. This is because different elements have different electron configurations and energy levels. So here is an example of what the spectrum looks like for hydrogen. So we'll have bands at 410, 434, 486, and 656 nanometers. Spectroscopy is the study of the interaction between matter and electromagnetic radiation, which we refer to as light for what we're talking about here. In emission spectroscopy, the focus is on the light emitted by the excited atoms as they return to their ground states. This technique is used to identify elements in stars, fireworks, and even lab experiments by analyzing the emitted light. We'll use something called the diffraction grating. Diffraction grating is an optical device made up of many closely spaced slits or grooves that disperse light into its component wavelengths, or colors. When light passes through or reflects off a diffraction grating, it spreads into its constituent colors, much like a prism, allowing us to see the emission spectrum of an element. Diffraction gratings are commonly used in spectroscopes to observe the emission spectra of different substances. So you'll have your light source here, and it will go into a diffraction grating. The diffraction grating will split that light out into different places. So you'll end up with something like this. And that is emission spectra.